Alright, ladies and gentlemen, in this video we're continuing our logarithm talk as we talk about the common log. And we're going to also be looking into this video of some key properties. The real goals of this video are to refresh what we know about common logs, but then also use four super important properties as a way to evaluate logarithmic equations. Let's first and foremost look on into the common log. Don't forget, guys, common log is base 10. I don't know how to make that any more clear on the screen that I have right now. Right? Common log is base 10. So what I want you to do real quick is just in your calculator evaluate the following functions just to kind of see what happens. So pause the video real quick, take a quick second, and put some values into your calculator. Alright guys, so I've put a few of them on in there, and so as we can see, when we have the common log of base 10 raised to the 10, it's the same thing as saying 10 to what power equals 10? Well, 10 to the first power equals 10. Good to go. Log with a common log, or log of base 10 of 1 over 3, gives us negative 0.477, so on and so forth. And then I wanted us to kind of see what was happening here when we substitute a negative number in. Well, the problem is that we are not going to have a negative value because of the range of these logarithmic functions. So you should have gotten an error when you substituted that negative value on in. Alright, into the four big properties of logs that we're going to be looking into for this video here. So let's first and foremost talk about some ones that are a little more common. Log with base a of 1 equals 0. Once again, that's like saying anything to the 0 power is 1. A to the 0 power is 1. 1,000 to the 0 power is 1. A gajillion to the 0 power is 1. So on and so forth. Log with the base a of a equals 1. Forever and ever. A to 1 equals a. 2 to the first equals 2. 8 to the first equals 8. 1 million to the first equals 1 million. They can go on and on forever. The two ones that we give some names to, alright, are the inverse and the one-to-one functions. Okay? So here's how this works. If we are dealing with log of base a of a to the x, it will equal whatever exponent is in that base. And likewise, if we raise base a to the log base a of x, that will equal x as well too. And so we're going to be utilizing some of these as a way to solve some equations that are coming on up. And then lastly, for a one-to-one function, or a one-to-one property, excuse me, log with base a of x, if that is equal to log of base a of a different value y, the only way this happens if x and y are equal to each other. Okay, that's the only way that this happens specifically. So how can we utilize this in some more application kind of based stuff? So in these examples, excuse me, I'm yawning. I'm sorry about that. Using the properties of logs to evaluate for a and b, we want to solve for x in this specific example. So for part A in this case, it says log base 2 of x equals log base 2 of 3. So what does this mean? How does this specifically solve for x? Well, what property does this kind of resemble? Hopefully you can see this is an exact use of the one-to-one property. Because if we have the same base, the only way these two logs equal each other is that if x equals 3, alright, or x equals y, like we showed in our example. Alright, well, log base 4 of 4 equals x. We want to solve for x. Once again, 4 to what power equals 4? So that's going to show that x equals 1 in this case. Alright, so what about part C and part D? I challenge you to pause the video before we go on into them and see if you can solve for part C and solve for part D. What do you think? Well, when we're diving on into part C in here, what does this look like? Well, hopefully you can see this is the first part of that inverse property that's happening on in there. We have log base a to the or of a to the x power, where the bases are the same, right? So if these bases are the same specifically, it holds true that log of base 5 of 5 to the x simply equals x. It equals what that exponent is, okay? And then for part D, it says 6 to the log base 6 of 20, okay? And I'm sorry, this meant to say simplify in here. Little typo. Simplify, okay? So what do you guys think? Well, this is again using our inverse property, but we're using the inverse property in a different manner this time. Now we are saying that, hey, 6 and 6 both match on up, those common bases that we have in there. So what was true is that if these are the same bases, this simplifies on down to 20. Okay? All right, ladies and gentlemen, let's see what you got. Do me a favor, guys. For questions 1 and 2, I want you to write the logarithmic equation in exponential form, okay? I've given you the log equation, and I want you to take this log equation and write it in exponential form specifically. See what you can come on up with, and we're on to the next one.